All right, everyone, welcome back. I'm Mark Beierl back with you again here to talk about PNFs, or working in brown fields. So, just a quick recap. I'm sure that you've all have seen this already, connecting to your remote desktop. Is there anyone who has just joined and needs a new VM or anything like that? No? All right, then we can skip over this. But basically, this is the OpenStack tenant. Over here, inside of OpenStack, is a firewall that we haven't been using. What we're going to be doing in this session is we're going to be sort of deploying a workload here, or I'm thinking at this point, we're just going to do an OpenStack create VM and just launch a VM there. And then we're going to show how this firewall can be managed by OSM to open a port so that we can SSH to our instance. I'm also going to show a little bit of info on how we can integrate with other things like Ansible so that you can figure out, be able to take advantage of Ansible playbooks. So, first thing is, why am I calling this brownfields and what's a PNF? Brownfield versus greenfield, in case you haven't heard these terms anymore. Greenfields is what we've been doing up until now in OSM. We have a brand new package, we have a brand new service, we launch it, off it goes into OpenStack and things are up and running. Brownfields, however, on the other hand, and these terms actually come from urban planning. A green field is obviously a green field. We're going to be building new houses and everything like that. Costs are lower because you don't necessarily have to worry about fitting in with the environment, but costs can be higher because you need to find the new place to put your stuff. Brownfields is redeveloping an urban core. So you're putting buildings in where buildings already are, and you've got to figure out how to work with the existing infrastructure rather than putting your own infrastructure in place. So, bearing that in mind, we have two terms, VNFs and PNFs. PNFs are considered high-cost units. This is an appliance that was sent to you by a vendor, and it's a fixed thing. You're not doing much with it other than operating it. Whereas a VNF is something that's supposed to sort of be, dynamically created. I should be able to just spin one up. There it is on my network, and when I'm done with it, I can take it away. Physical appliances, you need to physically do that. You need to have somebody present to install it and remove it. So the main thing about VNFs and PNFs is VNFs are recyclable. You can reuse that hardware to do other things on. Now, does that mean that a PNF is bare metal? Not always. PNF refers to a fixed function. We don't have a life cycle for it. But it could be something that's already in your network that somebody else manages a life cycle of, but you need to integrate with it. So the firewall was an example of that. Power DNS could be another example of that. Maybe we've got a DNS server already in our network, and we just want to be able to update it with our zone entries and host entries. So that's the whole thing about PNFs, is being able to take something that already exists, whether it's a VM, whether it's a physical appliance, it could even be a Kubernetes function. It doesn't matter. The only reason we call it a PNF, or we are using that term PNF, is because we are not managing the life cycle of it. We just want to use it. And, of course, VNF doesn't have to mean bare metal either, because you have things like OpenStack Ironic, which presents bare metal as if it were a VM. So it boots the bare metal appliance and does a pixie image to that bare metal appliance, and then you can change what's running on your bare metal. So VNF could be running on bare metal, and PNF could be a virtual machine. So here's our environment again. We have OpenStack and Kubernetes. We're going to be ignoring the Kubernetes now. There is the firewall that has been deployed already. We're going to deploy originally I was going to do Apache web server, but what we found out was that sometimes the load balancer doesn't come up, so I think we're just going to stick with a simple Ubuntu VM and we'll just SSH to it. And then basically we're going to have OSM tell the firewall, open the port, and then we'll be able to SSH to it. So what does this look like? You've got your OSM that's obviously on the same subnet as your OSM-X. You have a firewall that's already got a fixed IP address in your network, and you have a private network that that's behind the firewall. So how does one manage a PNF with OSM? You've got to be given information about that PNF. So what we need to know is how to find your network function, your physical network function, and as a developer or as an author of this ops code in the execution environment, you're going to need to know, how do I talk to it? Can I SSH to it? Is there a REST API? Is there an Ansible playbook? Is there a chef script, Puppet, whatever it is? That's the part that you would write and put together, and then OSM would execute that in a framework, that framework being the execution environment. Typically, and this is what we call proxy again. So it is not code that is running inside of the network function, obviously, because we're not allowed to install software in somebody's bare metal appliance or fixed function. So we have to create an area where the code can execute, a LXD container, a Kubernetes pod, and it will reach out over the network and configure your physical network function. So when we register this with OSM and we say, okay, deploy a network service over top of this, OSM is not actually going to launch any container or any VM, but it will still launch this sidecar or whatever we want to call it. It's going to launch this little execution environment, and that's where your code is going to live. So it's almost the same pattern as a VNF, except for the fact that we're not actually launching the workload. So we're using Vias as our firewall. If you need more information about Vias, it's there, but basically Vias could be put on bare metal, it can be put on a virtual machine, and that's what I happen to do for us today. Runs all over the place, open source, got documentation, etc., etc. And an important thing for me was it already had Ansible playbooks. So there's an entire network config set of packages under Ansible that you can use, and Vias happens to work well with them. So how does a primitive run? We've seen this before, but essentially we're going to, set up the network service so that OSM has an execution area for things to go, and then we're going to tell OSM execute an action, and it's going to turn around and talk to that container where our code is running and start executing the commands that we told it to. So that happens inside the proxy, and then in our case, it's actually doing Ansible commands over SSH, which is a very typical way of running Ansible. So we're not actually putting the playbook or anything in Vias. We're going to have Ansible installed in our execution environment, and Ansible is going to talk via SSH to Vias. That way, nothing has been installed. So we have, let me actually go here, we are on absolute bleeding edge here. So the first thing that I'm going to need you to do is when you get into your VM here, I would like you to go into OSM packages and do, enter, and do a git pull, please. So, oh, I forgot. I accidentally added all the delete of this dead code that we don't need anymore. But yeah, so when you do your git pull, you should get a large thing. So if everybody could go ahead and do that, we will then, after that, go ahead to Hackfest. Oh, yeah, there it is. Hackfest demos, OSM-MR 13, session 2.2 PNF. And here's where we have some of our little scripts here. So we'll just go ahead and start. Actually, let me display the contents of this in case anyone needs to see it. So this is what it looks like to register a package with OSM. Each PNF for BIOS has been created with your virtual desktop IP plus 100. So at the very beginning here, I am taking a look. Oh, sorry, this thing is really bad for scrolling. Let me see if I can move this just a little bit without going right off the top. There we go. So I'm actually just going, okay, I'm going to take your host name, cut off the last digit. That way I know you're 123, 100, whatever. I'm going to add 100 to that, and that's the IP address that we will be that I'm using. So that's how I figure out your IP address. Then, in case it gets run, a couple times, if we want to make any changes, I've got the deletes here. We've got our package uploads, which uploads it right from OSM packages, Hackfest, Firewall, PNF. So back in your home directory, back up at the top, this is not a package that is particular to this Hackfest. So it's not in common directory or anything like so it's not in our directory for the Hackfest. It's up in the common. So these are packages that we use periodically. Even in our daily regression suite that we run in OSM, we use some of these packages. So registering the PDU with OSM, you can see here I've given this, oh wow, that's a touch screen. I'm sorry. I've given this little thing here that shows the interfaces. So basically I'm telling OSM, here are the IP addresses where you can find things. So I'm letting OSM know about the public IP address of it, as well as its internal IP. Not that we would be able to talk to the internal IP, but if we did need to, or if OSM needed to come through a different interface, these are ways that you have of being able to say, okay, this is the management one, and this is how we're going to be using it. So we're just simply describing the function to OSM. So we can go ahead and run that now. The Git update is not needed to actually run this session. It's needed for you to be able to receive these scripts. So so actually, what I want to do, do I have, no, okay. Let me grab another terminal here. We're going to go code OSM packages. Yes, I trust you. Is it easier to read in light or dark mode? Dark is better for the screen? Okay. Okay, so if I go down here, down through here to Hackfest, Firewall, high contrast, okay. Oh, why is it, where did that screen go that I had here? Where's my preferences now? Sorry, I don't know how to get back to that screen now. It just had it. But yeah, that would have been good. Okay, so this is our network service descriptor. And it looks very similar to other ones where we're just sort of saying, what things are in here. And here you can see where we refer to the gateway public, and that's what we plumbed in the VDU create command that we did. So the one IP address, I said the 172.21.19.125, whatever, that is now associated with a label called gateway public, and here in the NSD, that's where we refer to it. So that's how OSM now knows, oh, okay, we have an IP address for this. The PNF looks like this. So we have our PNF here, and oh boy, stop moving around on me so much here. So we have, we're saying there's one instance to it, and we're describing what sort of things we can do in it. So you've got your operate and initial config. So here's where we tell information to OSM about how are you going to get into this PNF. So in this particular case, it happens to have a username and password credential. It could have been an SSH key. It could be maybe you don't have those things. Maybe you want to be able to specify an endpoint as far as a URL goes. That's where you would be able to put some of these things so that your operations code knows how to find stuff. So you can pass information through from the descriptor or as a runtime instantiation parameter. So I just made my life easy and gave a username and password to my Vias router, and we're just going to keep things simple. Down here we have, so here are things that you can run when it's done. I say, I would like to be able to add a port forward, and I would like to be able to remove a port forward. When I add a port forward, I need a rule number, because that's the way Vias works. You have to create rules by number. I need a source port that you want me to forward from Vias, and then I need to know what destination IP and port that's going to go to. Deleting a rule is really simple. We just delete it by number, and it's done. So, then comes a little bit more of the interesting part. Under charms, we have our source code for the charm, and I have some playbooks. I haven't implemented any actions to use all of these playbooks, such as remove port forward or perform a backup or a restore, but these are additional little playbooks that I just grabbed to be able to do a restore or perform a backup. So these are just standard, regular old Ansible playbooks. There's nothing magic in any of this. I can test this from the command line by running an Ansible, Ansible over top of this. Make sure it's all good. Do I like how it works? Yes. Okay. Now I put that playbook into my PNF package here. Bundle it up. Give it to OSM, and then OSM will run it for you. Yes, sir. Sorry, I turned that microphone off. While you're doing that, to ask the question, I'm going to grab myself a water. My apologies. Yeah, I'm just grabbing a water. I'm going to be right back. Is the battery dead? Oh.
Can you hear me? Yeah.
Yes, there we go now. Thank you.
Because in this use case, we are deploying a physical function. It's a physical function, right?
The function has already been deployed.
Okay.
The firewall is already out there and running.
Okay. So OSM is only sending an instruction to execute these Ansible commands to probably just to configure the rules and the actions. Because why I'm asking this, because in our environment we actually deploy the virtual machines end to end via Ansible scripts. So the function itself is already deployed.
Yes.
With the build script, right?
No. If you actually go in, take a look. So you can see here in my particular OSM that I'm going to be using, I have, I did just run the load. So I only have the packages here. But if we take a look in my instances, well, I have nothing here. If I look under PDU instances, I have this registered, but it's not in use. So as far as OSM is concerned, it only has a model, but it hasn't instantiated that model. The PNF was put there by the security group, my IT department or whatever. That is a function outside of my scope, but they have given me SSH access. I'm pretending. They've given me the access to be able to get into it to run some Ansible scripts.
Okay, that's it. And it's gonna only configure the the way how it will deal the incoming and ingress and outgress, outgoing
Yes.
requests. Okay, clear.
Okay. So this is what the playbook looks like, and I have myself a little helper function, and this is something, this code here sure is in the OSM packages, but what we don't have right now in OSM is a nice sort of library. It's like, oh, take a look at this package and copy it, and you'll be able to do an Ansible playbook on your own. But it would be really good if we could start getting sort of template libraries and things like that. So very specifically, where the glue is inside of my package, not in the OSM core. So you have to get my code here to be able to run the Ansible playbook. Inside of my package, I just wrote, you know what? Yes, let's go ahead and install the Python extension. libansible.py, here we are back here. So inside here, let me see, here's my Python code. So what happens is when the execution environment is first created, we have to do a little bit of setup inside the execution environment because, well, how did OSM know that I'm going to be running Ansible? It doesn't. The execution environment is like what I talked about before with native functions. It's just enough operating system to give you Python. It doesn't have anything else installed in it. If you need a Python package, you should include it in your inside of your descriptor. In this case here, what I am doing is I said, you know what? I'm going to go ahead and install Ansible from a PPA. And this particular function is going to, when we create the network service, we're not actually creating the firewall, but we are creating the execution environment, and when that starts up, it's going to run this code on install that installs Ansible by doing a, there we go, app install of Ansible. I have a little helper here for create hosts that basically just sort of says, okay, well, we know that we're going to be running this on the one PNF address that was given to us. So I can make a shortcut and just say, the information for Ansible, well, I know I'm only running on one host, so I'm just going to encode that right into the Ansible, Etsy Ansible hosts, write the inventory file and execute my script that way. Creating the Ansible config. Here is where we put like sort of our SSH connection, turn off host key checking because we don't want to get any sort of errors about, the host changing or anything like that. Then I do a find to figure out where I've been installed. And lastly, execute playbook. So we know that everything in our execution environment gets installed under var libjuju agents. That's a little tidbit that you may or may not need to know, but that's where you're going to find. If you enter into your execution environment and go into that directory, you will find your code running right there. So just simply open that up, do key replace in Ansible to replace any templating code, that sort of thing. And then we execute the Ansible playbook, we take a look at the output, and we return the output back to OSM so that it can tell us what happened. So that is the magic for Ansible. And essentially, Why is this not switching? Sorry, there it goes. Yeah, so that's basically it. The charm code itself, I think we've talked about sort of the life cycle of charms and the fact that the way Juju works is it gives us a bunch of callbacks that we can register interest in. So we say, okay, when you're after you've installed Juju and that framework is up and running, I'd like you to call me so I can perform my Ansible install. And that is what this, self-framework observe on install. So Juju, when you're deploying this into the execution environment, give me a call back once you're done your installation so that I can do mine. And that's where I implement my onInstall function, which basically calls that live Ansible install Ansible for us. So what does this look like then? So I have created the package, uploaded the package, and registered my PDU. So we can definitely, we can see that with OSM PDU list. It is a slightly different keyboard, so OSM PDU list. So that's the same thing that I showed in the web UI, basically. It'll tell you where it is and what the IP address is. And yeah, Ubuntu 23, that's where I am. So actually, I can SSH OSM at 172.21.19.123. It's going to ask me for the password, which, if you saw from the previous thing, was OSM 2021 exclamation mark? Or was it just OSM 2021? Yeah, there it is. Okay, so I'm actually in the firewall right now. And anything that would happen here would be, Ansible, not Ansible, sorry, Vios. So we're at a Vios shell type of thing. So this is exactly how OSM is going to talk to our firewall. So let's, oh, I'm hitting function, that's why. Control and function keys are at different places. I lost my window. All right, so we're ready to go ahead and launch our network service now. And this particular network service is going to use Lexi to create a container. So if I right now say Lexi list, I can see, okay, well, there's nothing in there. I haven't done anything. If I take a look at firewall watch progress, just a little something that it's basically an OSM-NS show firewall and only greps out status. So rather than, us looking at the full record, I figured I'd just show this here where we can see, status is creating, deployment of KDUs, Vim, and execution environments. Well, we're not actually deploying any, nothing in Vims, but we are creating an execution environment. And so, it's going through and saying, okay, this is the sort of stuff that we're doing for it. It's mapping it. And I may have filled in enough time now that I can say Lexi list. And we can see there is suddenly a container that was managed by Juju that is running. So, you're not normally going to do this, but I'm going to say Lexi exec Juju bash. So, this is same as, docker exec-it. We're going to enter into the container, and I can take a look around. This is my execution environment. cd, var, lib, juju, agents. So, there's our unit, Vios config. OSM will give it a name that is based off of the network service and VNF. So it sort of puts these sort of things together to create the application name. So if I go into the unit, VIOS config, in here, oh yeah, so here's my charm source. So here's the source code that I had. It's already there. If I take a look at charm/playbooks, the playbooks have been copied to it. So what we put in the descriptor, OSM has packaged that up, taken the code parts out of it, and pushed it over into the container for us. And we are now kind of, up and running with that. Interesting things that you can look at here are things like var log juju unit. Here, oh, there it's running. Sorry. Here is where it says, oh, okay, I see. We know that, here's the unit created. Now it's saying, okay, we're going to call the install hook. And you can actually see it says installing Ansible. So, the var log, juju log, basically, whatever you print inside of your charm code will show up in this log here. So we can see that this thing is up and running, juju's running, which means now when I log out of this VM, OSM-NS list, I should see that it is done. Yes, it is done. So, everybody there so far? So far, so good? Okay. What I'm going to do then is, okay, so cat launch workload just does an OpenStack server create on the private network. Launching a workload behind the firewall. If I go over to my OpenStack now, let me increase the font size a little bit here. Admin domain Hackfest 24, password Hackfest. And just a quick view at the network topology. Pardon? Password for OpenStack is also Hackfest. So Hackfest dash your number, password Hackfest. And if you mix your number up and you log into somebody else's, you might not know it unless you take a look at the upper right-hand corner to double check that you're logged into the right tenant. So this is what we have now. We have OSM over here, we have VIOS here, and we have a workload way out here behind the private. You'll notice that OSM has no path to it. That is 239.217 on my screen here. So if I go over here and I say ping 192.168.239.137. Did I say 137? 217, sorry. Obviously, I'll never be able to reach this because that's a subnet that I'm totally disconnected from. There's no way of OSM being able to get to it at all. So, what I was showing was 4 run actions here. So, what I need to do is I am going to run an action that says, aha, what, sorry. So, my destination address is 217, and because you saw that I did an SSH to port 22 of the firewall already, I obviously can't port forward for port 22, or I won't be able to talk to my firewall anymore, and that's it. I've lost control of it. So I'm going to forward port 5022. So just before I do that, to show that there's no smoke and mirrors here, SSH Ubuntu at my firewall 172.21.19.124. Sorry, no, that's not what I meant to do. I meant to say SSH-port 5022. And connection refused. So I now go in here and I have copy and pasted my command and changed my IP address accordingly. And it says, okay, the action is in progress. I can do something like do OSM-NS operations list. What did I call this again? Sorry, firewall. That's what the name of my NS is. So if I do an OSM-NS op list, firewall, this tells me what actions. Remember in the web UI, we've got the GUI way of seeing actions that were done. This is your exact same view. And I can see that the action port forward has been completed. I could do something like OSM-NS operation show, and then take this ID, and it's going to tell me a little bit more information about what happened. So here you can see that there was a warning that came from Ansible. It says, warning, invalid characters were found in group names, but they weren't replaced. Don't worry about it. It's okay. It's just a warning. And Ansible's standard output says, okay, playbook was run, and there you can see result is 172.21.19.123. Okay, changed 1, failed 0. So I've got my Ansible output right here from OSM. So now when I go back and I try my SSH command, connection refused. Why? What happened? Oh, hold on. Did I... Oops. Whoever has... I don't think I gave out a tenant 23, but I just realized that I accidentally gave the wrong PDU address. No, I am OSM 23. Sorry. I meant to go to 123 then. Sorry. It's been a busy week. I'm going to try an SSH to my firewall. I swear I had this working.
I believe you.
Sorry? Oh, I know why. I know why. Because I'm in Hackfest 24. Remember what I said about signing into somebody else's tenant? Guess what I just did? Hackfest 23. Hackfest. Actually, just to make things easier, I'll go over here and I'll say OSM-NS VNF list. No, I don't have it in there. Sorry, I meant OpenStack server list. We didn't deploy it with OSM, so I can't get the IP address from OSM. So OpenStack server list, and here I can see that it's 60. Okay, so cat 4 run actions. So what I'm going to do is I'm going to say do this, and I'm going to remove my port forward. Okay, that's queued up to run in the background. And now I'm going to do add port forward, and I'm going to put in the correct IP address. Mine was 60, because that's what it says up here. It's 60. So we go ahead and run this now. And if we look at the previous one, OSM-NS op show, just to make sure it ran correctly. So we can see that the remote port forward worked well. And what was our, well, I'm sure the other one worked as well. So now let's try our SSH. And now I am in the workload. Plain and simple. So that allowed me to open the port and come out. So that is, kind of about it for physical network functions. What we saw earlier in different sessions in the Hackfest, and what I wanted to actually do with this one, was show how you can use relations in a network service. So remember, like for Prathika's example with the Next EPC and the MME and the gateway, how two things were able to exchange IP addresses. Well, you could include this PNF of a firewall as a PNF, and you include that descriptor in your network service. So I say I have a network service that contains this function and that function and this PNF VNFD wrapper. And then I can cause them to be related to each other, so that way when a service becomes available, it'll automatically punch a hole in the firewall. Or maybe I've related it to DNS. So when the service becomes available, it automatically adds the IP address with the zones and hosts that it needs. So what did I want to do next that I thought would be interesting for people? I decided then, rather than going over that, we would take a little bit of the Hackfest and Cat 5, Start Debugger. So at this point, what I thought we'd do is flip over a little bit and let's start looking at OSM code directly. So there are two different installers for OSM. One is a simple bash script that basically installs Kubernetes from upstream sources, installs Juju, essentially creates all the pods and everything with a bash script for OSM. The other installer we have is what's called the Charmed installer. And all that means is, instead of it being bash scripts to configure everything, we just wrote Juju charms. So the same way we've got day 1, day 2 actions for network services that you can run, there's kind of these day 2 actions for OSM through the use of the charms. So if you've installed Charmed OSM, we can do things like, say, Juju config, and we're going to take a look at our LCM module. And what we have here is there is a whole bunch of variables that can be set on it. One of them is, does this work to scroll up? No. Okay, I'm going to very carefully scroll up here. No, maybe not. Debug mode. Great for OSM developers, not for production. This isn't the type of thing that you want to actually do in production. We have ways of locking it down so nobody can do this. But if you happen to have Charmed OSM running anywhere, you can flip to debugging it on a moment's notice by executing this command. It also allows you to do things like set host paths for the code. So say I'm a developer and I have my OSM code checked out. And I want to test something that I just changed, but I don't want to build a whole container and deploy it and wait for it to reload and all that sort of stuff. If I flip LCM or RO or whatever over to debug mode and tell it, instead of the code that's in your container, just mount my directory in the container and run the code, run the container as if you were running production, but with my code mounted from the host right here. So that's a way, and when you're in the debugger then and you make a change to a line of code, it gets written right to your disk. And then you can get committed when you're happy with it. So let's go ahead and cat number 5, start debugger. Yeah, well, you don't have to copy paste these. You can actually rerun it. But I'm going to go ahead and just copy paste. And you can see I'm saying, okay, Juju config LCM debug mode true. I don't happen to have the OSM code on any of our workstations here, so I'm not actually going to tell it to use local source code. I'm going to say, I want to debug what you have in your container right now. Then we can run one more action, because flipping over to debug mode can take a little bit of time. If I take a look at my Juju status here, of course, you can see that the LCM has gone into maintenance mode, starting debug. So until such time as the maintenance mode has exited, the LCM isn't operational right now. I have effectively taken it out of service and told, hey, restart with the debugger and debugger support. So when I do this, oh, sorry, it's already, what, cat 5. I now want to get a little bit of information out, because we don't want to make it easy for just anybody to now enter our container. So what we have is information about how to get into the container now. So it's obviously still running the setup, so this is just going to sit here until it's ready. So if anybody has run this, number 5 script or anything like that, and it's just sitting there and nothing's happening, that's because the action is still waiting. And it's basically going to come back with a command to execute that will launch VS Code as a remote debugger inside the container, and it's given me the randomly generated password for SSH. So now, if I can find my... There we go. So I'm just going to go ahead and run that command. Here my VS Code is starting up, and it says, oh, extension SSH is required to do this. So you want to install it? Yes, I want to install it. So we'll wait for that to go, and in the meantime, I'm going to go over here, and I'm going to copy my password down. Copy. Go back to my VS Code window that just opened up here. It says, oh, you want to continue, you trust this container? Is that the right SSH fingerprint? I don't know, but it's a Hackfest, so yes, I'm going to continue. And here is where I now get to paste my password and hit enter. So I'm going to bring this one full screen now and show you what we have here. Sorry, it's still, still setting up the host. Okay, do I trust the content? Yes, I trust the content. So if we look in the Explorer, I can now see OSM LCM. Here is all of my LCM source code. Scroll down a little bit, I see OSM Common. That's another module for OSM, and here's all the source code for that. And as I mentioned, if I had said, let's change the configuration to say common host path equals my home directory / OSM Common, you would still see OSM Common here, but the content would be served from your desktop. Or from the host that code is running on, I should say. And so then there's the N2VC code. What I'd like everyone to do now is we're going to go into, down at the bottom here, N2VC jujucon.py. And we're going to go down to around line 13. You know what? Sorry. Find exec primitive. Okay, so around line 916, we'll go into this exec primitive. And, sorry, scroll down a little bit more here. Here it is, line 1051. And what I'd like you to do is put a little red dot right here. That red dot is a breakpoint, which means that when I tell OSM to execute an action, eventually the breakpoint is going to be hit and the debugger will become active and we can see our variables and step through code. So the first thing that we need to do here, oh, sorry. The first thing we need to do is actually go to our debugger mode within VS Code. And you'll see up here, there is a pre-filled in debug configuration for you called LCM Workspace. To the immediate left of that is a play button. When we press this play button, we are starting up the debugger. Now LCM is running under the control of the debugger. And as you can see from the bottom there, the LCM log is now being shown in our VS Code workspace. So all this sync download stuff that's happening will take a moment to finish while it's loading. So while that's happening, oh, there we go. Okay, LCM is all up and running and it's happy on this particular node. So now I Alt-Tab back to my terminal and I say, okay, sorry, what were my actions again? Here it was number 4, cat 4, run actions. And I'm going to say, okay, for me, because I already did the port forward, what I'm going to do is my action, I'm going to run remove port. I'm going to run the remove port. Okay, so that's happily going and things are happening off in the background. OSM is busy working. If I do an Alt-Tab back to my debugger, I can see stuff is happening down here. It's, syncing content. And, oh, look at that. I hit a breakpoint in my debugger. I now have variables. So when we go in here, let's get rid of these. We can see the call stack that happened here. The fact that there's this run once, run forever, run until complete. This is part of Python's async IO library. So we know, just based upon our call stack, that we're actually in an async method, and this is a coroutine that's being called back. So the unfortunate part about async in Python is that I don't know who called me. So the call stack starts with the function that's called, but I can't go back through my call stack and say, well, who was it that initiated this call? There's ways of finding it out, but it's not easy. But anyway, so here we can say we're in this call stack. Let's minimize this. Okay, we can see there's some information. What's our application name? Vias config Z0 Vias PNF VNF. We know the application in Juju that's being run. We have an execution environment ID. This is the internal identifier that OSM uses to know what Juju is being used for this. Because you can create 2 network services and each have their own execution environment. And so OSM needs to keep track of them separately. So we just use a regular UUID for that. I have a reference to my live Juju with the information that it has in it. I have my model that I'm running in. I've got the parameters that were passed to OSM at the command line. Remember I said I want you to delete rule number 10? Where here it is coming in. And you can do things like, I accidentally made a mistake. I meant to delete rule number 11. Well, rather than going in and letting this complete an error out and go back to the command line and say, okay, this time delete rule number 11, you literally can go right in here and change this 10 to an 11 and continue debugging, and it'll go ahead and do that as we want. So what we're doing here is we're saying, okay, for this particular thing, we want to execute this action. We've got our a primitive name that we're running called remove port forward. We've got the rule number. We've got the parameters that were set. There's going to be a timeout of 1,800 seconds. And it's a LXD proxy charm that's being executed. So we've got, this sort of information here. So F10 steps over the debugger. So if we want, we can go ahead and, or you can also use this one here to step over lines. So we can go ahead and do that, and it is going to executing action port forward, remove port forward, action is being executed in leader, action status completed, and oh, my debugger came back to me. I now have output and status. So here I can see, oh, what's my output? Well, it's giving me the, I'm trying to see if there's a way of getting this to open up in a more full screen way. It's not a lot of room here. But anyways, it's got all the information, the last line of output that Ansible gave us is what came back in our output. And so that's what we received here. And essentially, that is the way it works. And the OSM code now says, well, if the status of the action was equal to completed, then we're just going to go ahead and return the output. If it happens that we didn't have any output, then we're going to look and see, well, did they at least give us a key that says, well, here's the output from the command, and if the status is not completed, we're going to look to see, well, did the code return output? Did the charm that you wrote, the proxy charm code, did it return something on standard out for us to use? If it did, then we're going to say, oh, okay, there was an error executing it, but here is the output I was given. Pass that on up to the OSM user and let them figure it out from there. Otherwise, if there is no output that was, when you wrote your charm, if you didn't give any output, then it's just going to, OSM's got no real chance to do anything about it other than to say, no further information was received from the action is the hard-coded string that comes back if you don't specify any output in your code. So I'm going to go ahead and hit function F5 now and let this continue executing. And off it goes. It removed the port. The action is completed. So this went way faster than I thought. So who would like to ask me anything? This is the open session. So from any of the previous sessions, because we've got Gilson here, I think I saw Pratika over there. So open it up to questions about PNFs, questions about OSM, things that you want to try, anything. Did I go too fast on the PNF? Everybody got the concept, or? Sorry.
No, it's quite clear, but this is like, a more of a new, because this is the OSM code itself, right?
I'm on the wrong side of the speakers to hear.
Yeah, they're pretty high. I mean, for me, it's a new thing.
Yes.
I was not into the code part yet, but this is interesting.
It's taking us to the next side of OSM, basically. And, it wouldn't be a Hackfest without us hacking into some code. So, one thing that we could do as well is, okay, I'm going to, actually, where's my breakpoint here? I'm just going to go ahead and get rid of my breakpoints. Make sure there's no other breakpoints. It's still running. Okay, so I'm just going to go ahead and minimize this window and leave that running in the background. Now, remember I said we have this live Ansible Pi, and it calls, the Ansible playbook, and it says print result is last line. Well, what happens if I want to get more output? So here I said, last line equals the whole decode and everything like that. Well, maybe if instead I want to return last line. Okay, let's just try this here. It's a Hackfest, why not? Return result. Let's see what happens here. Is it, oh no, result dot decode UTF-8. Okay, so I am going to return all of the output now inside of here. So I go ahead and I save this. I go back here, and I have two choices. One, I can, just upload a new version of this package and then tell OSM to upgrade to it. Or two, I can do an OSM-NS delete firewall, tell it to tear down the environment, and then cat2, was it? Launch network service? Yeah. Actually, show this here, LXC list. We'll notice the execution environment is gone because I told OSM. It didn't delete the firewall. It didn't touch the firewall. It just tore down the execution environment. So if I go ahead now and I do number 1 again, build firewall, I change the package right here on my local host, and now I'm just basically going, okay, upload the new code to OSM, and we'll deploy it, and then we'll try adding the firewall rule and see what the output looks like now. And then 2. Oops, that's me putting output there. It's not actually saying 2 package created. There it goes. Launch that one. Or we can actually do the 3. Oops. I already did launch the workload. I don't need to launch it again. 4. Which was it? Oh yeah, it was called Firewall Watch Progress, just to see how it's doing here. Still creating. But again, Lexi list. I can see that the container's been created. Lexi exec juju bash cd var lib juju agents charm machine 0. Oh, right, it's still starting. Okay, let's wait for OSM to finish deploying. OSM-NS list. Building instantiating still. The other thing that can be done... All good? Okay. The other thing that can be done is when you're developing, like that live Ansible that I showed you there, that code that's running in the charm, what we did is we went from the outside. We made the change in the package, we re-uploaded it, we deployed it. That can be a long time. My little developer trick is I will sometimes do, that same lexd exec, go into the container, and if you can't remember where the code goes to, you can always do a find var /name equals charm.py. And here it says, oh, okay, there it is. Lib unit, agents, BIOS, charm. So you can go right into, sorry, I meant to say CD, go right into there. And you can always do things like vi charm.py and edit it right in here. And when you're happy with it, take that code, put it back on the host file system. That's one way of being able to, do it a little bit more quickly. But any changes that you make inside of your execution environment will not persist. So if you're making changes there, remember to take your code out and bring it back into your package directory, because it's going to be a one-way. So let's go ahead and get... oh, sorry. While I'm thinking of it, let's just go down to the bottom of this file here, Shift-G, and we can see that... Oh, sorry, it was a live Ansible that we changed. BI, lib, charms, OSM, live Ansible. So here was that live Ansible, and you can see here is the code that I changed. It's already been deployed to it. So we know that the code made it in there. And now let's just see, well, what does it look like when, oops, I did not mean, oh yes, I did mean to exit that one. Recall add port forward. So it's going to go ahead and execute this now, which means that my new code is about to be executed. And if I do an OSM-NS op show of my operation, it's probably still running. Well, by the time I correct all my typos, it will be done. OSM-NS op show. Processing still. You can see up at the top here it says processing. It's a slow one today. Yeah, in the op show, you will actually, see what was being called, so what parameters were being called. So there is an audit log in OSM as well of what actions were performed, sort of who initiated it, what it is, what values did they give, etc. So we keep logs, and this operational params and this sort of thing, the execute operation and have this data that went out, that's actually in the Etsy spec defined to a certain degree. So it's, come on, are you done yet? Oh no. I bet you. Am I still in the debugger? Oh, wrong. No, this is the one. No, this is to run and debug. It's my other VS Code window. It is still running. Okay, well, it's slower in the debugger, folks. Done yet? I should have turned off the debugger before doing this. There we go. And oh, look at all the output we got this time. So there you can see now it has returned a lot of output. So we can control how much information comes back, what information we want to put in there, and how it works. So it's a relatively straightforward thing. So yeah, you can see, well, that is literally the whole Ansible output, the playbook, everything that got executed. So there we go. Is there anything else that we can do that would be interesting to see?
The source code of OSM is being managed by the community itself.
That is correct.
Okay, and how you communicate together with the weekly meetings, which features should be added and which new features should be added to that, and
Okay, so we have a couple things. https osm.etsy.org/GitLab. GitLab, and unfortunately, if you just go to GitLab, it's going to ask you to log in.
Yeah, this is what I tried already. So.
However, I said there it is. And I don't know why the dashboard only does that. But if I were to send you to, so type in osm.etsy.org/GitLab/OSM. Try that.
Can you put it on Etherpad?
Yes. I don't have the Etherpad open here right now, but Etsy, osm.etsy.org pad/p/OSM. No? Somebody took it down off of there, so. OSM-MR 13 _Hackfest. I think that was it. There we go. Okay, wow. Somebody's got the resolution on this thing set to tiny. Oh, yes, so sorry. This was what I had wanted to do in terms of deploying the web server. Pratika was kind enough to add this down here for me, but I didn't get a chance to, make sure that everyone could do this. So if you want to try and deploy your web server behind the firewall and show opening of port 80, you can also follow these instructions here. Or port 443. Is it 80 or 4? It is 80. Okay, thanks, Pratika. Okay, so OSM source code. First thing that I wanted to see was let's first take a look at this feature project. Copy that. It's Control Tab. So this is where the features are kept. And if I now go to OSM features and I say sign out, and then I go here to the Etherpad and I hit this, I can see the features with a sign-in button. So you should be able to browse through different areas of OSM without needing an account. So this here is where we, this GitLab is a mirror of our Gerrit repository. So in OSM, when you make a code change and you want to submit it for review, we're still using Gerrit, Jenkins, and Bugzilla. We're not using GitLab at this time. We have moved our feature tracking over to GitLab. So that's what that features project that you saw is. And in here we have got issues, boards, where we can do things like, okay, this is a board that our end user advisory group looks at to decide what sort of things we're looking at, or looking for contributors. Ladies and gentlemen, I invite you to contribute to an OSM feature. Anything that's looking for contributors is over on the approved there, event-driven LCM RO, command line parameters to get a list of primitives and their details. These are all little ideas, little projects. If you happen to be, hanging around with university, and you are a friend of yours or a child of a friend of yours is in university, they're in a master's degree, and they need a master's project, we can make one for them and help them along with it as well. Not only do they benefit of having a project and a mentor, but we also benefit because we can move something forward in OSM. So this is something of value to note, that we do work with universities and help students with their projects, and that way we all win. So we can look at the OSM source code. That LCM that I was talking about earlier, that I showed you in the debugger, happens to contain the library called N2VC and happens to contain a library called Common. So earlier I was mentioning about the N2VC. Here is where the source code for that one is. We go down to N2VC. And there's that N2VC juju.con. And what did I say it was? Somewhere around line 1033 or something like that. Oh, here is where we were on... No, that's the else. There's the get actions. Well, anyway, sorry. I was trying to find what the exact line of code that we were looking at earlier, but I don't know where I put it. I think it's somewhere further down. But anyway, so this is the same source code, basically, as what was running in that container. And so we do have... actually, Sylvia mentioned in some of the beginning slides, or actually, if I go to my presentation here, no, I need to get out of this. Okay, we did our port forward. So here we go. Join us, learn how to join. There's this here. And it's just sort of getting involved in OSM, requesting an account just as a participant, create an individual contributor or user account, and then we also have documentation on things like getting the source code, looking through Bugzilla or whatnot. But the getting the account is free. Whatever that will allow you to log into GitLab. The other thing that having an account allows you to do is be able to propose a code change to OSM. So if there's any code, like if now that you all know how to debug and you find something that doesn't look right and you're going, oh, if only I could change that, you have the power to change it now. And we welcome that. So, yeah. So that is the... Was that the welcome? Thank you? Yes. No, that's the... Yeah, here's where I was in mine. So, and try OSM. This is the two ways of installing OSM that I mentioned. There's the one that installs everything at a lower level and configures it all. And then there's the one that has these Juju charm scripts on top of it. It is the same OSM code. It's the exact same code. It's just the environment around it that's different. And because, we can do things like package up scripts with the Juju, we can do things like create this debug mode, and it can configure itself instead of us having to tell you, okay, run this, execute that, do this other thing. So that's the only difference between charmed OSM and regular OSM. Anything else? Oh, I know what else. We have... Where's my GitLab? Oh, I was using it in the other. So, GitLab, osm.etsy.org/GitLab/OSM/features. We go here. Nope, that's not what I want. If I go here, and I want to look at all the different groups. Nope, that's asking me to sign in. Want to look at all the projects? Nope. BNF-onboarding / no. I'm sorry, I'm going to have to log in and never. Not OSM. I want to go to OSM user guide. I will put this URL into the Etherpad, which I believe I had open in the VM, so I have to do this again. OSM. There it is. Okay, so this link down here that I put in the Etherpad is a new tutorial that we've been working on. One of the things in OSM is our documentation has been developer driven primarily. So we don't have a technical writer in OSM as part of the project. We don't have somebody with really strong stylistic guidelines, etc. And it just so happens that we've been looking at a documentation framework called Diataxis. And the principle behind that is that there are 4 types of documentation. There's your tutorials. A tutorial is on Rails. It is do this and you will see that. It is explicit, guided instructions on if you follow these commands exactly, this is the result you will have. Then there are the how-to guides, which is, well, I already know, the general idea, but I just want to know, how do I get, a piece of information? How do I do one thing and one thing only? That's a how-to. Then we also have references, which are, like glossary, explanation of terms, things like that. What was the 4th one? I'm drawing a blank. Explanation. So diataxis. So here is what it looks like essentially. And so what we've decided in OSM is we're going to start seeing how tutorials work. We want to get a feel for what it looks like. And so once we're talking about the different areas here, we decided for ourselves that that's going to be the first place to start. We're also looking for contributors in this area. So if you're finding some of the OSM documentation a little bit dense or a little bit hard to work your way through, this is a very important contribution that you can make to OSM. It's the type of thing that, the code is one thing. People go out and install the code and something else for you to be able to say, hey, they're running my code right over there. There's also a satisfaction to improving the world by sharing your knowledge. And this is something that when I was younger and in high school, I wanted to become a high school English teacher. I ended up writing software instead. So I come here and I get to pretend I'm a teacher in front of all of you. I get satisfaction from that and enjoyment and fulfillment. And now that I'm looking at this here and I'm kind of going, oh, this makes sense for a framework, I'm getting more excited about documentation as well. So just sharing a little bit of my passion. But there are many ways of contributing and many ways of even opening a bug. If you open a bug in OSM Bugzilla, I'm happy. Not happy that you found a bug, but happy that people are using it and caring enough to let me know what works and what doesn't. So we encourage you, find something wrong, open a bug. Find documentation that's wrong, please. We're welcome and open for you to fix it. Like I said, obviously you'll need to have an Etsy online ID in order to be able to open a bug in Bugzilla, but it's free. So it's not a huge barrier. Lastly, on that, it may be a case of, well, this is a bug that I found, but I don't. Yeah, maybe you're not wanting to sign the contributor agreement or whatever it is, and you don't necessarily want to go through all of that. Well, we're on Slack as well, and you can come, talk with us at any time, and maybe we'll end up opening the bug for you because it's just easier to do it that way. So, yeah.